And in this module, we explore more data binding features and transform bound data with pipes. To provide a great interactive user experience, we want to bind DOM elements to component properties, so the component can change the look and feel as needed. We can use bindings to change element colors or styles based on data values, update font size based on user preferences, or set an image source from a database field. And we want notification of user actions and other events from the DOM, so the component can respond accordingly. For example, we respond to a click on a button to hide or show images. And sometimes we want the best of both worlds, using two-way binding to set an element property and receive event notifications of user changes to that property. In this module, we'll use Angular's property binding to set HTML element properties in the DOM. We walk through how to handle user events, such as a button click, with event binding, and how to handle user input with two-way binding. Lastly, we'll discover how to transform bound data with pipes. And here, once again, is our application architecture. We have the first cut of our product list component, but it doesn't have any interactivity. In this module, we'll use data binding features to add interactivity to the product list component. Let's get started. Property binding allows us to set a property of an element to the value of a template expression. Here is an HTML image element. We bind the source property of the image to the product's image URL, effectively defining the source of the image from information in our component. With property binding, the element property is enclosed in square brackets, and the template expression is enclosed in quotes. For comparison, here is a similar binding using interpolation. When using interpolation, the element property is not enclosed in square brackets, and the template expression is enclosed in curly braces with no quotes. When binding to element properties, many developers prefer using property binding over interpolation. Plus, property binding allows binding to types other than strings, such as a Boolean true-false value. Interpolation always assigns a string. But if you need to include the template expression as part of a larger expression, such as this example, you may need to use interpolation. Like interpolation, property binding is one way from the component to the HTML element property. It effectively allows us to control our template's DOM from our component. Let's add some property binding to our sample application. Here we are back in the editor, looking at the product list component and its associated template. Let's use property binding to bind the source of our product image. We use an image element to display our product image, and we'll use property binding to bind the image's source or SRC property. So we enclose the SRC in square brackets. On the right side of the equals, we define the template expression in quotes. We want to bind to the product's image URL property from the product list component class. Let's also use property binding to bind the title property of the image to the product's name. Let's check out the result in the browser. Whoa, they're big, but we do see images. If we hover over an image, we see the image title. But this image is rather large for display in our table. Let's use property binding to set some style properties. Let's add properties for the image width and image margin to our component class. The image width is a number, so we specify its type with a colon and then number. Let's set it to 50. The image margin is also a number, and we'll set it to 2. Back in the template, we use property binding to bind the image styles. We want to bind the style property width in pixels. We'll bind that to the image width property from the component class. Notice that we don't prefix this property with product, because image width is a property of the component class, not the product object. And we do the same with the style margin in pixels, and set that to the image margin class property. So now we've seen how to use property binding to bind several properties of the image element to properties of the components class. Before we look at the result, let's talk about TypeScript's type inference. To learn about TypeScript's strong typing, we've been adding data types to our properties. However, if we set a property's default value, we often don't need to specify its type. TypeScript will infer the type from its value. For example, since the page title property is assigned to a string, we don't need to specify its type. TypeScript will infer it as a string. Same for the numeric values. If you use a linting tool, it may flag any properties with an unnecessary data type. Feel free to remove these unnecessary types. I'll leave them here for reference. Now, looking back at the browser, our image sizes look much better. But our images are always displayed. The Show Image button doesn't work yet. To hook up the button, we need to respond to user events. Let's do that next. So far, all of our data binding has been one way, from the component to the template. But there are times we need to send information the other way to respond to user actions. For example, to execute some code when the user clicks a button. A component listens for user actions using event binding. Event binding allows us to connect an event to a method in the component. Here is an HTML button element. We bind the button's click event to the toggle image method in our component. When the user clicks the button, the binding executes the code in the toggle image method. With event binding, the event name is enclosed in parentheses. The method name is followed by open and closing parentheses and is enclosed in quotes. Wondering where to find a list of valid HTML element events? Check out this link. The Mozilla Developer Network provides a thorough list of standard events, along with some documentation. Now let's give event binding a try. In this demo, we want to implement our Show Image button. First, we define a class property that keeps track of whether the images are currently displayed. We'll call that property Show Image. Since this property is true or false, we define its type as Boolean. And let's set its default value to false, so the images are not displayed when the page is first loaded. Next, we build the method that the event binding will call. By convention, methods are normally created after all of the properties are defined, so we'll put it down here. Let's name the method toggleImage. Notice that TypeScript does not require any keywords such as function. Following the method name with open and closing parentheses identifies it as a method. Our method won't have a return type, so we specify the return type as void. The body of the method simply toggles the state of the Show Image property. The bang or exclamation point used here is a logical NOT operator. It returns false if its operand, Show Image in this case, is true, and true if Show Image is false, basically toggling the value from true to false or false to true. Back in the template, we are ready to set up the event binding. On the button element, we define the click as the target event by enclosing it in parentheses. We assign it to our method enclosed in quotes. When the user clicks the button, the binding calls our method. So the only thing left is to actually hide or show the image. Recall how we add logic to add or remove HTML elements from the DOM? If you said the ngIf directive, you are right. We'll add ngIf to the image element. We only want this image element if the Show Image flag is true. The image element will then only be added to the DOM if Show Image is true. Let's see if this works. Are we ready to give it a try? Click the button, and the image appears. Click the button again, and the image disappears. Oh, very cool. The only odd thing is the button text. When the image is displayed, the button text should change to Hide Image. So up here where we have the button text, let's use interpolation. When Show Image is true, we want the button text to say Hide Image, and when Show Image is false, we want the button text to say Show Image. We accomplish this using a JavaScript conditional operator. We specify the condition, which is show image, and a question mark. Then we specify the true expression. So when show image is true, we want to display hide image. Then we add a colon and the false expression. So when show image is false, we want it to say show image. Basically, we can read this syntax as, if show image is true, display hide, otherwise display show. Let's check this out in the browser. So our button text now says show image. If we click it, it says hide image. Ah, that seems a little more user-friendly. Cool. Before we move on, let's talk a moment about Angular's change detection. By default, Angular is constantly watching for changes to any bound properties and listening for events. In our sample application, we have a button that shows or hides images. In the HTML for the button, we bound its click event to a method in our component, and we used interpolation to change the text of the button based on the value of a property in our component. We used the ngIf structural directive to add or remove the image element from the DOM. The showImage property is initially false, so the button text displays showImage, and the ngIf removed the image from the display. When the user clicks the button, Angular executes the method bound to the click event. The code in the method toggles the showImage property from false, its default value, to true. Angular's change detection detects that change and automatically re-evaluates all the bindings. The interpolation changes the button text from show to hide, and the ngIf adds the image element to the DOM, displaying the image. This is the Angular way to modify DOM elements. Now that we have our images working, let's tackle the filter by box. And for that, we need two-way binding. When working with user entry HTML elements, such as an input element, we often want to display a component property in the template and update that property as the user types. Here we set a default list filter to cart, and if the user changes the filter, we want the list filter property to change as well. This process requires two-way binding with the ngModel directive. We enclose ngModel in square brackets to indicate property binding from the component property to the input element, and parentheses to indicate event binding to send a notification of the user-entered text back to the component. We assign this directive to a component property. To help us remember which order to put the two sets of brackets, visualize a banana in a box. Square brackets for the box on the outside, and parentheses for the banana on the inside. Recall that a directive is custom syntax Angular provides to power up our HTML. The ngModel is an Angular directive. Each time we want to use an Angular directive in a template, we need to consider how to make that directive visible to the Angular compiler. Remember how we do that? If you said an Angular module, you are right. The illustration of our app module currently looks like this. We want to use the ngModel directive in our product list component, which is owned by app module. So in the app module, we need to import the appropriate system module that exposes the ngModel directive. Since the ngModel directive is most often used when building data entry forms, ngModel is part of Forms module, so we import that here. Now the ngModel directive, and any of the other Angular Forms directives, are visible to any component declared by app module, including our product list component. Now let's give this a try. We are back in the editor and looking at the product list component and its associated template. Recall that we defined a filter by input box here and display the entered filter here. We'll later use the filter to filter our list of products. Let's start by adding a component class property for the list filter. This property is a string and will set a default initial value for filtering the list of products. We hard-code the filter string here, but you can imagine that we stored the user's last entered filter and use that as the default instead. With that, we can set up the two-way binding. On the input element, we draw a banana in a box, then specify the ngModel directive. We bind to the component class listFilter property. We want to display the listFilter here, so we use interpolation. Recall that interpolation has no quotes. Are we done? Not quite. Let's open the terminal window. We see an error, can't bind to ngModel since it isn't a known property of input. This is telling us that Angular can't find the ngModel directive. Recall from the slides that the ngModel directive is part of the Angular module for forms called Forms module. To expose this directive to our product list component, we need to import the Forms module in the module that owns the product list component, which is our app module. We start by importing Forms module from Angular Forms. We then add Forms module to the imports array for the ngModule decorator. Why the imports array and not the declarations? Our directives, components, and pipes are declared here in the declarations array. Directives, components, and pipes we use from other sources, such as Angular itself or third parties, are defined in external Angular modules we add to the imports array here. Now that we've told Angular where to find the ngModel, let's see the result. When the page displays, we see cart as the default value. It is displayed here and here. If we modify the entry, notice that the displayed filter text is also updated. That's because we are using two-way binding. Notice that the list of products is not yet filtered. We'll do that in the next module. There is one more thing we do want to address now, and that is the data formatting. That price should really look like a price and show the appropriate currency symbol. With Angular's data binding, displaying data is easy. Just bind an element property to a class property and we're done. Well, not always. Sometimes the data is not in a format appropriate for display. That's where pipes come in handy. Pipes transform bound properties before they are displayed, so we can alter the property values to make them more user-friendly or more locale appropriate. Angular provides some built-in pipes for formatting values, such as date, number, decimal, percent, currency, uppercase, lowercase, and so on. Angular also provides a few pipes for working with objects, such as the JSON pipe to display the content of an object as a JSON string, which is helpful when debugging. We can also build our own custom pipes, as we'll see in the next module. Let's start with a simple example. Say we want to display the product code in lowercase. We can add the pipe character after the property in the template expression, and then specify the lowercase pipe. The product code is then transformed into lowercase before it is displayed. We can also use pipes in property bindings. Add the pipe after the property in the template expression and specify the desired pipe. In this example, we specified the uppercase pipe, so the image title will appear in all caps. If needed, we can chain pipes. In this example, the price is transformed into a currency. By default, the currency pipe adds the all caps three-letter abbreviation of the local currency to the amount. If we want to display that abbreviation in lowercase, we can transform it again by simply adding another pipe. Some pipes support parameters. Parameters are defined by specifying a colon and the parameter value. For example, the currency pipe has 3 parameters: the desired currency code, a string defining how to show the currency symbol, and digit info. The digit info consists of the minimum number of integer digits, the minimum number of fractional digits, and the maximum number of fractional digits. The value here of 1.2-2 means at least 1 digit to the left of the decimal, and at least 2 digits to the right of the decimal, and no more than 2 digits to the right of the decimal, effectively defining 2 decimal places. With that, let's jump back to the demo. We specify the pipes in the template, so we are looking at the product list component template. Let's add a lowercase pipe for the product code and a currency pipe for the price. For the product code, we simply insert the pipe character after the property in the template expression and type lowercase. That's it. For the price, we insert a pipe character and currency. That's all that is required. But let's try out a few of the parameters. We'll specify USD symbol to display the $sign instead of the currency abbreviation, and 1.2-2 to specify that we want at least one number to the left of the decimal place, and two and only two numbers to the right of the decimal place. Let's see how we did. Looking at the result, we now see the product code in lowercase, and the price displayed nicely as a currency. So we can easily perform simple data transformations using the built-in pipes in the template expressions for our bindings. Feel free to try out some of the other pipes from the slides. Let's finish up this module with some diagrams and a checklist we can use as we work with bindings and pipes. Data binding makes it easy to display component properties and set DOM element properties from our component to better control the view. The component can listen for and respond to events, such as a button click. And with two-way binding, we can process user entry for an interactive experience. As we've seen, there are 4 basic types of binding in Angular. Here's a diagram as a memory aid. Interpolation inserts interpolated strings into the text between HTML elements, or assigns element properties. Be sure to wrap the template expression in double curly braces and no quotes. Property binding sets an HTML element property to the value of a template expression. The element property must be enclosed in square brackets, and the template expression must be enclosed in quotes. Event binding listens for events from the user interface and executes a component method when the event occurs. The event name must be enclosed in parentheses, and the method to call when the event occurs must be enclosed in quotes. Two-way binding displays a component property and updates that property when the user makes a change in an input element. Use the banana in a box syntax with the ngModel directive. The template expression must be enclosed in quotes. Here are some things to remember when using ngModel. Define ngModel within the banana in a box for two-way binding. Be sure to add Forms module from the Angular Forms package to the imports array of an appropriate Angular module, in this case, app module. This ensures that the ngModel directive is available to any template defined in a component associated with that module. We'll talk more about Angular modules later in this course. The data we have in our component may not be in the format we want for display. We can use a pipe in a template to transform that data to a more user-friendly format. To use a pipe, specify the pipe character, the name of the pipe, and any pipe parameters, separated with colons. Here is an example of the currency pipe with 3 parameters. And here, once again, is our application architecture. In this module, we finished more of the product list component, but it could be better. Next up, we'll see several techniques for improving our component.